Hello class, welcome to this video on section 4.6. We're going to be talking about polynomial inequalities and rational inequalities. So let's get started. So here we have our function, and the first thing we need to do is solve, and we've been solving for 0 for the past few sections. So we take this and factor it, and we get it to our factors x plus 1, x minus 5. And again, if you ever need some more practice or some videos, you might want to YouTube or Google some videos on, again, how to factor a polynomial, a trinomial into these factors. So once we get it to here, notice also too, I changed the inequality sign from greater than to equal sign because again, we're just right now trying to solve for and get our zeros. So if this is x plus 1, we already know this is going to be a negative 1. And then if this is x minus 5, we know it's going to be a positive 5 for our two zeros for this particular one. So the next thing we need to do is kind of make yourself a chart. Write down interval, test value, sign of the function. And we're going to go ahead and make our intervals. So the first answer we have for this one was negative 1, correct? So our first interval is going to be from negative infinity, so all the way to the left, negative infinity, to negative 1. That's our first answer. That's our first interval. Our next interval is going to be from the negative 1, so we start from here, negative 1, and we're going to go to 5. Where did 5 come from? 5 came from our 0 for the second part. So we have from negative infinity to negative 1, and then from negative 1 to positive infinity, to 5. Now we're going to go to 5 into positive infinity now. So that pretty much takes care of the whole number line from negative infinity to positive infinity. So for this particular one now, we're going to start with the first interval, and all we have to do is find a test point or a test value. So just choose a number in between negative infinity to 2, from negative infinity to 1. I just chose 2 in this case, negative 2. It doesn't matter which number that you choose. It's just when you get whatever number that's in between negative infinity 1 and negative 1, plug it in for this x, plug it in this for and this x, and get our answer. If you plug this negative 2 into here and do the math, we get 7. Is 7 positive or negative? In this case here, it's going to be a positive. Again, we choose a test value for in between negative 1 and 5, and 0 is pretty much the easiest one to use as a test value because this goes away once you plug in 0, and you're left with negative 5. So we put it here. And then choose a number in between 5 and infinity. We're going to choose, for this one here, we chose 7 and got 16. So what is the reason for us doing this interval? Because again, the answer for this particular problem is not negative infinity to negative 1, negative 1 to 5, and 5 to infinity. So this is what you probably need to make a note of. A lot of students, when we get to this problem, they write this the answer, this is the answer, and this is the answer into MyMathPlus and wind up getting the problem wrong. For this particular section, you have to do what is this test value to figure out which one of out of these three is actually going to be the correct answer that fits into this function here. So for this one case here, we notice that we have 2 positive answers and 1 negative answer. So which one of these answers makes sense into this problem up here? This side over here should be greater than 0. So looking at these numbers, which one of these numbers is greater than 0? Is going to be the 7 and 16 because it's positive. So don't you agree? Anything that's actually a positive number that comes out of here once we plug a number in is always going to be greater than 0. So this is actually the only ones that we're going to be using. The 0 in this interval, we get negative 5, which doesn't make sense in here because negative 5 is not greater than 0. So this is the only interval we could put a big X on because we're not going to use this interval. So the only answer, 2 answers for this particular one is going to be the interval of negative infinity to negative 1, and then from 5 into positive infinity. And to put the 2 answers in, you must put a union. So we're going to put a union sign for this one here and this one here. It should be located in the bottom screen of your MyMathLabs Plus when you work it in there. So once again, just to recap, once we find our zeros and then find our intervals for each one, remember, There could be a time where you only have one particular answer as far as an interval, or two answers. Not necessarily all of them is going to be the case as for the answers. You must do your test value check to see which one is actually a positive or negative. And this symbol here will let us know whether we need a positive as an answer or a negative as an answer. So it's always best to set this whole side over to the right equal to 0. Then we know that we should have a positive or negative as our answer. So here's our second example. So once again, we want to make this over here, bring it to this side and set it equal to 0 to make sure we get our zeros and figure out if we're going to be using positive numbers or negative numbers. And because we have this less than or equal to symbol, what we're looking for is this side over here must be less than 0 once I bring the x over and then the 3 by subtracting. So if I have left over here, this is gone, and we have 0 over here, and it needs to be less than or equal to 0. That means this side over here needs to be a negative answer once we do our test values. So we brought this over by subtracting. So here's our minus. Bring the 3 over by subtracting. Here's our minus here. Combine like terms. I have a 3x here and a minus x. That makes the 2. And then the minus 5 minus this 3 gives us the minus 8. Then we go back to our skills of factoring to figure out what our factors is going to be for this particular one. For here, there is no, I didn't put the factor up here, but if you factor these out, you're going to have x plus 4 and x minus 2 as our two factors. What I did here was give you another option to try to figure out our zeros. I think you probably remember this from the previous sections on how to show you to get the zeros from this factor here. So you will put in for your first part for y1, you put this equation in for y1. So hit y equals in your top left hand corner of your calculator. Type this in for y1, and then for y2, remember we put 0 for y2. We hit zoom 6. And then to look at the graph, remember the ones that has colors, you'll see a red and a blue line. So maybe the blue is going to be the parabola, and the red actually is the red line going across the x-axis. If you have just a TI-83, which I'm showing here, you have to pretend that there's another line on the x-axis that we're going to need to solve this problem. So then we hit second trace and then number 5, because number 5, we're trying to find the intersection of the parabola and the intersection of the x-axis, which this is our first one, and then over here will be our second one. This is the same two graphs, so we need this answer and this answer. So once we hit second trace number 5, go to where you think it is. It don't have to be exactly in the spot, and hit enter 3 times. 1, 2, 3, and then you have your answer of 0, -4, which is the same thing as saying x plus 4 up here as far as our factor. And then for the second one, you have to hit second trace number 5 again in your calculator, and then slide it over, and then hit enter 3 times over here. And this will give us the x minus 2 as far as our answer. So these are our two answers for the 0. So then we go ahead and put it in our interval and then make our chart and do our test value. And then once we get our test value, our points, like we did before here, so we go from -infinity to -4, and then from -4 to 2, and then from 2 to positive infinity. Pick a point in between those intervals, plug it back into this equation, and see which one of those intervals is going to provide us with a negative number, because that's going to be less than 0. Those is going to be the interval answers for this particular answer. And in this case here, -4 to 2, and I put a bracket around, because brackets includes when you have less than or equal to, you put brackets. If it was just less than, you just put a parentheses. But the -4 to 2 was the only interval that when we chose a number in between here, gave us a negative answer, which is actually the solution for this problem. Our second option you can do also is just you can actually leave them separate. So you don't have to bring this over to this side, this over this side. Now again, if you like the first way, you can just bypass this part and go to the next example. But those of you that's looking for another option to solve this problem, if you put in y1 that's the left side, and then put a y2, that's the right side. And then for this one here, we do our same thing. We hit zoom 6 to see what the graph looks like. And again, we have two answers, 1 and then 2. And then for this particular one here, again, we hit second trace, number 5, go to where they intersect at. That's the first one, hit enter 3 times. And then you still get our answer of -4. To hit second trace, number 5 again, shoot up to this part over here, then hit enter 3 times. And then that's when we get the other one of -2 for this answer for x. Once we get our x's, then we get our intervals, plug it back into the equation just to make sure, again, we're looking for here. So looking at this one here, it kind of holds true from the -4 all the way to the +2. We notice that down here are all negative numbers for y's. They're all going to be negatives. That's why the negative is the only one that's going to work, because that's where it's going to be less than 0 for this problem. So only from -4 all the way to 2. So from this interval here, anything that's going to be less than -4 or greater than 2 are positives because they're above the x-axis. So here's the answer. Here's the part for the second one when we get to. Here's another video that you can watch, but I'm going ahead and go through this one to help you with a solving for rationals. Once again, you need to get rid of the denominator. The best way to get rid of the denominator is just multiply by the LCD. In this case here, since this is the only denominator, we'll multiply both sides by x plus 6. That will cancel out with this one. So this side over here, x plus 6, these two cancel. This one goes away, this one goes away. If you multiply it over here by this 0, everything goes away because anything multiplied by 0 is still 0. Then all I have is with the numerator, divide both sides by 3, and we still get x equals 0 in this case. Now I'm going to show you another way for checking. Those of you that to do the test intervals again, if you want to put this into your calculator, you can also do the same thing and put it into your calculator. So let me show you how to do that. So we'll go to our y equals, type in our equation or function, 3x divided by x plus 6. And then we can hit second window, and we're going to go down to where it says independent, and we're going to switch it to ask. So here now the calculator is waiting for you to import an x that we need to test. So this is where you put your test value in that we talked about before. So these test points here, -2, 0, 1 for these particular intervals is what you're going to put in for the calculator part in order to figure out the test values. In this case here, I chose -7, -2, and 2. So let's go to our calculator, and we should get these same results here. And let me go ahead and explain the answers as far as the test file here. So for this one here, remember our answer is going to be 0 and -6. Now we did the math and found 0, but where do you think -6 came from? Do you remember in the previous section where there is a problem when we ask for the domain? If you see a fraction, you're supposed to set the bottom one equal to 0 and solve for this one to get our 0 for this one, because again, we don't want anything that's going to make this whole problem undefined. So if we put a 6 here, a -6, -6 plus 6 is 0, which makes 0 on the bottom, which makes the whole thing undefined. So our two zeros for this part here is going to be -6, that came from the denominator, and then when we actually solve the problem for this particular one, we got 0 for this one. Now the previous one, this is just for rationals, because if you look at the previous examples I did before, they didn't have anything as far as a denominator on the bottom. So there was no purpose of us trying to figure out those domains or figure out what's going to give us undefined. Only with rationals is you have to solve the problem, and you're supposed to get your zeros from the denominator. So we need to pick a number in between negative infinity and 6. That's why we chose negative 7. Then we need to choose another number in between negative 6 and 0. We chose 2. And then from 0 to positive infinity, that's when we chose 2 for this one. Again, all these three answers is not what you need to put in for your test or the evaluation quiz or the homework assignment. You can't put in all three of these intervals, because again, one of these needs to be marked off. It could be marked off, and we got to figure out which one it is. For this particular one, what are we looking for? Because it says negative, less than, this side over here, our answer, and once we plug in for x here and here, our test value, this side must be a negative number because it has to be less than 0. So for these answers, we're looking for that negative answer. So let's go to the calculator. If you put in here negative 7, you get 21. We put in negative 2 for the next one, and then 2. And we get our answers. Looking at this one here, the only negative one that provides us is the second interval for a negative number. So if that's the case here, this second interval is the only one that's going to be the actual answer for this problem. Now again, you don't have to choose negative 7. You could have chose negative 8, negative 10. It does not matter, so long as it's supposed to be in between these two intervals. Here you could have chose 1. You could have chose negative 5. So long as it's in between these two intervals, it doesn't matter what the numbers you choose for the problem. Then we have our calculator to help us figure out if it's going to be positive or negative. In this case here, we needed a negative answer. So here's another example. Again, you want to make sure this is set equal to 0. So let's bring the negative 1 over to make it minus 1. And then we have to find the common denominator. In this case here, it will be 2x minus 4 because that's the only denominator. Once we figure out the denominator, we multiply everything by the least common denominator, which is 2x minus 4. So multiply this one by 2x minus 4, this one by 2x minus 4, and obviously this one by 2x minus 4, but this is still going to remain 0 on this side. So that goes away, the bottom part here. The 2x minus 4, they cancel out, so leaving with just x plus 1. And then if we multiply this negative 1 and distribute to the 2x minus 4 here, we're going to get the answer to be, so I think it's better for me to actually work this out for you so you can actually see it. So remember again, this is considered to be my LCD, so I'm going to multiply this side by 2x minus 4, this negative 1 here by 2x minus 4, and then by the 0 by 2x minus 4. Anytime you find the LCD, you got to multiply it to each part into the equation or the function. So in this case here, we see that this 2x minus 4 cancels out with this one. And then and then I'm left with x plus 1. And then we're going to take this negative 1 and times it by the 2x minus 4 up here. So I'm going to have distribute. So this negative 1 times here gives me a negative 2x. Then this here gives us a positive 4. And then over here, anything times 0 is still going to be the 0 for the answer. Then we combine like terms. So I have an x here and a negative 2x here. That gives me a minus x. Then I have a 1 here and then a 4 here. That gives me a plus 5. So I can flip all the signs to make everything, to make this x equal to be positive. So this is going to be a positive x minus 5, and then that's still going to be 0 in this case here. And then if we add 5 to both sides, this gives us the x is equal to 5 in this case. So 5 is going to be one of our zeros. And remember, our second 0 is what we get from the bottom one here. So we take that off to the side and say 2x minus 4 is equal to 0. Do plus 4. That cancels. 2x is equal to 4. Divide both sides by 2. We have x is equal to 2. So in this case here, we have our 5 and we have our 2 as our answer. So here's our answers, the 2 and the 5 that we got from our problem here, the 5 and the 2. For this particular one here, here's our intervals, negative infinity to 2, and then from 2 to 5, and then 5 to positive infinity. So let's choose a number in between here. I chose 0. Choose a number between 2 and 5. I chose 3. And then 5 and infinity, I chose 6. We put these three test values in our calculator. Once we get our y equals set to the equation, like so, you just put this equation right here into the calculator for y1 to figure out our test values. We get our test values of a negative number here, positive here, negative here. So what answer are we looking for? We're looking for negative answers, or we're looking for positive answers. Looking at this one here, remember it has to be less than. This side over here must be less than, so less than has to be a negative because it has to be less than 0. So we need our first interval as our answer, and then our second interval as our answer. So we have our union sign, and again, we put for the 5 part, we have to put a bracket around the 5 because we're doing the less than or equal to. We don't put a bracket around the 2 because if we put 2 into the bottom part here, 2 times 2 is 4, minus 4 gives you 0. Remember, there's 0 on the bottom, which we cannot have a 0 on the bottom. So we can include 5, but we cannot include 2. So also be careful as far as when to put a parentheses and when to put a bracket in your answer, because the MyMathWise Plus will mark it wrong if you put a parentheses around this 5. Even though you had all the intervals correct, the one little parentheses here will throw off the whole problem and get it wrong. So make sure you know when to do the parentheses and when to do the brackets. So here we have our final example. We're going to take this whole part of here and move it over here by subtracting. And then we're going to find out what our common denominator is in this case. But here we can go ahead and get our zeros out the way. We know that x cannot equal -4 for this side because it gets a undefined. And then over here we can't use 5 because it gives us undefined here. So we already going to know we're going to use -4 and 5. We just got to solve the problem to get our third test value or critical 0 for this one. So once we solve, we're going to multiply both sides by the LCD, which is going to be x plus 4 and x minus 5. So here I took both sides over here, multiplied to this side and also to the 0. Again, the right side is not going to matter. That's why it's always best to set the right side equal to 0 because everything over here kind of goes away and you're left with just zeros. But over this side here, this x plus 4 will cancel out with this x plus 4. So this one and this one cancels out, leaving you with just on top. So let's multiply x minus 3 and x minus 5 together right here. And then if we multiply these two again over here, we have the same x minus 5, x minus 5. So that goes away and this goes away. So the only thing we're left with is x plus 2 times the x plus 4, which is here. So we go ahead and FOIL this to get x squared minus 8x plus 15. FOIL this, and then you have x squared plus 6x plus 8. Remember, we have to keep the second part in parentheses because we have this negative sign in. Got to distribute. This becomes negative. This 6x becomes negative, and this 8 becomes negative. Got to distribute that negative inside. A lot of students don't put the parentheses around the second part, and all they do when they write down the answer is just going to be negative x squared, and then they keep the plus sign and the plus sign down here, which is incorrect. So put it in parentheses to know that we need to distribute this understood 1 here to each part. We get down to this line, collect like terms. We get down to negative 14x plus 7 equals 0. Move the 7 over, divide, and we get our answer to be -1/2. So here's our test value for our intervals. So we have -4, 1/2, and 1. Always kind of put them in order. So this is the smallest one, this is the next one, this is the largest one. Put them in order that way. That way we know we go from -infinity to the smallest one, and then we go from -4 to 1/2, then 1/2 to 5, then 5 to infinity. So we actually got 4 this time. We got to get 4 test points. 1 from here, one from here, one from here, one from here. And what answer are we looking for this particular one? Here, we're looking for something to be greater than 0 once we move this over. If it's going to be greater than 0, it needs to be a positive answer. So we're looking for positive answers in this case. We chose -5 from here, -2 came from here, 3 came from in between here, and 6 came in between here. Put in our calculators. After we do our math, we see that the one with the 5 that came from here is an answer. So we put a check mark over this one. And then the 2.5 came from this one here, and we put a check mark over that one. So this one and this one is the only ones that's going to give us the true answer of a positive answer. Do not put the ones that has negative as the interval into your answer for MathPlus Plus. Again, remember also the bracket. The 1/2 gets a bracket because we can include it because that's the number we solve for. But the -4 does not get a bracket because that's a 0 that was on the denominator. Can't have zeros on the denominator, undefined. And that gave us the answer for this one. So if you have any questions or concerns, let me know for this section of 4.6.